Hello, wherever you are, I hope you're having a good day and that you're ready to take a look at another exam question. So this question is about an organic reaction mechanism. Related topics include organic reagents and conditions, naming and drawing organic molecules, reaction mechanisms, specifically the terms nucleophile, electrophile, addition, substitution and elimination reactions, and curly arrow notation. Reagents and conditions at the top of the list are really a lot of marks to be gained just by knowing the content, and naming and drawing molecules similar really. Practice them, know your functional groups, and being able to name them is going to enable you to pick up marks and also help you to understand the majority of organic questions. So pause the video, read the question and have a go. Press play when you're ready for the answer. The convention that I will be using is black, the question itself, blue, the model answer, and red, any additional information. So curly arrows show the movements of a pair of electrons. This is always linked to forming and breaking of covalent bonds. A nucleophile is an electron pair donor. An electrophile is an electron pair acceptor. Okay, so let's take a look at the answer for this. We said earlier that you need to be able to name and draw molecules. It's going to be very impossible, perhaps, to get full marks without knowing the structure for 1-bromo-2-methyl propane. There it is, 3 carbons in the longest chain, so propane. The bromine atom is on carbon number 1, and there is a methyl group on carbon atom number 2. The hydroxide ions come from the sodium hydroxide. We showed a lone pair of electrons on the hydroxide with those 2 dots, and it is minus. The sodium ions are spectator ions and they do not appear in the mechanism at all. There is a slight dipole on the carbon to bromine bond because of the electronegativity of the bromine atom being greater than the electronegativity of the carbon atom. This was not required for the question, however, I think it's a good idea to include it. So those 2 electrons on the hydroxide ion are used to form a covalent bond with the carbon atom with a delta plus on it. Also, the carbon to bromine bond breaks, and so the curly arrows are showing the formation of the carbon to hydroxide, and they're showing the breaking of the bond between the carbon and the bromine. Straight arrows show the transition from either a reactant to an intermediate, or as in this case, a one-step mechanism, the transition from a reactant to a product. There we have our 2-methyl propan-1-ol, again, 3 carbons in the longest chain, methyl group on number 2, and the hydroxide, the alkyl OH, is on carbon number 1. We have also got the bromide ion shown there, so the bromine is no longer bonded, that bond broke in the first step, and the bromide has got the 2 electrons shown by the 2 dots and a full negative charge. So the type of mechanism is nucleophilic substitution. The nucleophile in the first step is the hydroxide ion, a species which donates a pair of electrons, and the hydroxide ion has replaced or has been substituted for the bromide ion. So the hydroxide is substituted for the bromide. Nucleophilic substitution. Thanks for watching. New videos are added regularly, so subscribe if you don't want to miss out. Any questions about this video and requests for future content are very welcome. You can email or post in the comments. Take care.